Okay, so we are going to be talking now about the shifts that go on along with this. So transformations happen exactly as well as they have for every other function here. Okay, so anytime you have something on the inside, it is going to be horizontal. Remember, if you are in prison, that is because you have done the opposite. Now, the difference is, where is the inside? Well, the inside is going to be actually up in the exponent. Okay, so the inside is going to be up in the exponent. Okay, now outside, that's going to cause our vertical shifts. Your outside is going to be anything that is in front of the base or added or subtracted back behind it. Okay, the important part I think to understand with this one here, the base determines your parent function. The base has nothing to do with horizontal, vertical, anything like that. The only thing the base does is it tells you what your parent function is. Okay, and then the last thing that we have here is negatives. And of course, remember your negatives make it flip. These can flip horizontally. These can also flip vertically. Okay, so we do need to make sure we know the difference if the negative is on the inside or if the negative is on the outside. So let's run down through and do some examples of these. Okay, I've got y equals 3 to the x power minus 2. First thing that I have to do is I have to graph my parent function. That is just y equals 3 to the x. Make my chart, x and y, -1, 0, and 1. It's always -1, 0, and 1. -1 goes with the reciprocal of the base, so that would be 1/3. 0 always goes with 1. 1 goes with 3. So I'm going to plot those points. Do not forget my horizontal asymptote. Okay? Now, where is that -2 at? That -2 is not up in the exponent. It's not up in the exponent. So this would be on the outside, which means that it is vertical. Okay? So remember, on the outside, we do what we're supposed to do. So each of my points moves down 2 spots. My horizontal asymptote will also move down 2 spots. Okay? Now, I told you guys when we looked at this, I would talk to you a little bit about the domain and range, just because this is going to be a little bit different. Your domain is still all reals because there's nothing stopping it going left, nothing stopping it going right. Your range, however, has changed. What's my lowest y value now? Look to your asymptote. It's at a -2. Range is still dealing with your y. The lowest y value is -2. So we could say that it's all the y values that are above that. So y is greater than -2. Again, we only do the greater than because it cannot touch that asymptote, but it gets really, really close to it. Okay? All right, let's look at another one here. Okay? Again, I have the exact same parent function. Remember, you just draw your chart to figure it out, but it's still 3 to the x. So I've got the exact same ones as before. Don't forget your horizontal asymptote. Okay? Now, where is the +2 at on this one? Well, you guys can see that +2 is smaller, right? So that is because this +2 is on the inside. So this is an example of what it looks like on the inside. Now remember, +2 makes us think we're going to the right 2, but we always do the opposite on the inside. Okay? So now each of my points shift over to the right. Oops, no. We always do the opposite. Sorry. Looks like it goes to the right, but it's going to go to the left. So we go to the left 2 spots. Okay. Does my horizontal asymptote shift? Yes, it does, but it doesn't look like it because it's just an infinite line. So it's just kind of like I'm pulling that rope. It's still going to look like a rope as I pull it to the left. Okay. Again, for this one, your domain for this is still all reals. Okay. All of these will have a domain of all reals. Okay. However, my range for this one, notice my asymptote didn't move. So my range would still be y is greater than 0. Okay. So now you guys kind of have an example of what an inside shift looks like, what an outside shift looks like. Okay, so make sure that we can tell the difference on those. Refer back if you need to. The next thing that we have is dealing with our two negatives, and then we will be done. Okay, new parent function for this one. I've got y equals 4 to the x power for my parent. Okay, that negative is not a part of the parent function. That's just a shift. So I've got -1, 0, and 1. -1 is the reciprocal. What's the reciprocal of 4? 1/4. 0 always goes with 1. 1 goes with 4. So we've got 1/4, 0, 1, -1, 1/4. Don't forget your horizontal asymptote. Okay. Now negatives make this flip. Where is this negative at? Remember, the only way that something is on the inside is if it is up in the exponent. That negative is not up in the exponent. So this is on the outside, which means that I'm going to flip down. So instead of 1/4, I've got 1 -4. All these points flip down. Your asymptote just stays the same. Okay? So there's an example of an outside flip. Okay? Same as before, domain is still all reals. Okay? Now my range, though, I don't have a lowest point anymore. I'm still dealing with y's. I'm still with 0, because 0 is still where the asymptote is. But now all of my y values are less than 0 as I'm looking through those. Okay? We've got one more. What do we do if the negative's on the inside? This is back to that original parent function. So we'd have 0, 1, 1, 3, -1, -1. Don't forget your horizontal asymptote. Okay? So this one here, you can see the negative is on the inside. It's up in the exponent. So this is going to be a horizontal flip. So my point over here flips over to this side of the axis. 0, 1 is already on it. And then my fraction one also flips over. Your horizontal asymptote flips over. It's not going to look any different though. And that is an example of what a horizontal flip will look like. Okay? We will be practicing these when you guys get back to class next time.